Hi everyone. In this video I'm going to demonstrate two-way repeated measures ANOVA when you have one between subjects factor and one within subjects factor, and we will be focusing in on SPSS. So also let me note that underneath the video description you will find a link to the SPSS data file used in this video presentation. You'll also find a link to a supplemental PowerPoint that I will be referring to during this presentation. So be sure to download both to follow along. So let's get started. So in a previous presentation I discussed and demonstrated the use of repeated measures analysis of variance when you measure an outcome variable repeatedly within a single group. But it's oftentimes the case that repeated measures analysis is applied to data involving more than a single group. So this approach, for instance, may be used in cases where the researcher hypothesizes that the variation in means associated with repeated measurements on the outcome varies across groups. And this effectively translates into a hypothesis concerning an interaction effect between the repeated factor and a grouping variable. So one might adopt this approach when testing whether differences in means observed over time are the same or different across levels of a grouping variable. And if differences are found, it's possible to examine whether the mean differences reflect different trends over time. This can be particularly handy if one of the groups being compared is a control condition and other conditions are experimental in nature. This approach could also easily be used when testing whether individuals react the same or differently across levels of a repeated factor and a grouping variable, and basically with the repeated factor representing or reflecting different stimuli to which a person is exposed. Now for our current example, the between subjects factor is going to be treatment group, which is coded 1 for control group, 2 for treatment A, and 3 for treatment B. And we are going to test whether there are significant mean differences in anxiety scores over 3 measurement occasions, as well as whether there are group differences in terms of how the means vary over time. So here I've opened up my data and you can see I've got the between factor, which is treatment group. Just taking a quick look at it, you can see 1 is control, 2 is treatment A, and 3 is treatment B. And then we also have our repeated measurements with respect to anxiety. So it's anxiety at time 1, time 2, and time 3. So let's go ahead and carry out the basic analysis by clicking on Analyze, then General Linear Model, and Repeated Measurements, or Repeated Measures. Under within subject factor name, I'm just going to go ahead and give it a name called time, and number of levels is 3 because we have 3 measurement occasions. So I'll click Add. Under measure name, I can give the repeated measures a name, so I'll just call it anxiety, and then click Add right there, and then Define. So we'll move treatment group to the between subjects factor box, and then anxiety T1, T2, and T3 I'm going to move over to the within subjects variables. Under options, I'm going to click on descriptives, effect size, power, and also homogeneity test, since now we have a between subjects factor. Then I'm going to click on estimated marginal means, and I'm going to highlight all of these and move them over to the display means box. And since I want to also incorporate pairwise comparisons of means between the different time points, I'm going to click on Compare Main Effects and then select Bonferroni. So next we'll click Continue, and then under Post Hocs, if you want to look at between group differences overall with respect to anxiety, we can move treatment group over here to the box on the right and then click on Tukey to get that. Under Plots, I'm going to select time and move it to the horizontal axis and click on Add, and then also I want to plot out any type of interaction that might occur between time and treatment group. So I'm going to move time to the horizontal axis and treatment group to separate lines, then click on Add. Where it says chart type, I'm going to leave it as line chart. If you want error bars, you can also click on that. So we'll click on Continue and then on OK to get our output. So you can see we have our descriptives, we have multivariate test results that are given, there's our univariate test results, and so forth. So rather than kind of going through all of these in the output file, which is a little bit difficult to read, I'm going to refer back to my PowerPoint in describing the results. So in terms of the first part of the output, you can see that we have sample sizes as well as the means and standard deviations. So with the descriptive statistics, you can see that we have the means in terms of anxiety at time 1 for the control group, treatment A, treatment B, then at time 2 for the 3 groups, and then at time 3. Okay, so the next part of the output contains multivariate test results. So you'll see down here we've got multivariate tests, and these can be used to test the main effect of time and then also the time by treatment group interaction. There's also another set of tests which contain univariate test results to do essentially the same thing. Now, with respect to the multivariate tests, it does make an assumption which is called the equality of variance-covariance matrices. In the context of our current model, we're essentially looking at the variances and covariances of different scores between or across the groups. So essentially, if this test result right here is statistically significant, then that can call into question the validity of our interpretations with respect to the multivariate test result. But it is important to know that this test, which is Box's test, is sensitive to multivariate non-normality, and it can actually increase the rejection rate in terms of that particular assumption. So basically concluding that the assumption is violated when perhaps it's not. Also, the multivariate test results are fairly robust when you have equal or nearly equal n's in your groups. So in other words, if you have a ratio that's less than ratio of the largest n to smallest n that's less than 1.5, then the test tends to be more robust, and that actually tends to be the case in our current situation. So you can see right here I've outlined the test results with respect to time and time by treatment group. So there are 4 different multivariate test results that are presented. Wilks lambda tends to be one of the more commonly presented results. So you can see right here that we have Wilks lambda for the main effect of time. That effect is statistically significant, and then the time by treatment group interaction effect is statistically significant. So that's basically telling us that the variation in means on anxiety over the repeated measurement occasions is itself varying as a function of treatment group membership. Okay, so in the next part of the output, you can see that we have these tests of within subjects effects. And so that's for the main effect of time and then also the time by treatment group interaction. So as you can see, we have 2 sets of tests that we could refer to theoretically. We could refer to the multivariate test results, or we could refer to these univariate test results. The multivariate test results and the univariate test results both make assumptions concerning independence of observations and normality. The multivariate test result makes no assumption concerning a condition referred to as sphericity, whereas the univariate result does make that particular assumption. And in the context of the univariate tests, a violation of sphericity can translate into increased type 1 error rate. Now there are a couple of ways in which we could assess sphericity in this particular table above. One is to utilize Mauchly's test. So you can see right here we have a p-value that's given, this sig right here, and if this is greater than say 0.05, the conventional threshold, then that would be an indication that we have sphericity being met. The only thing about this test is that it is affected by non-normality, and it's also impacted by sample size. So it does make this test a little bit untrustworthy at times. So for that reason, various authors have suggested just using the Greenhouse Geyser, and in particular just using some rules of thumb for judging the level of departure from sphericity. So basically this epsilon parameter value of 0.936, that is essentially kind of an estimate regarding the degree of departure from sphericity, and an epsilon value that is equal to 1 would be consistent with sphericity. So in a nutshell, you'll notice that in these tests down here, we have sphericity assumed, Greenhouse Geyser, and when felt, both for the main effective time and then also for the time by treatment group interaction. So if you can assume sphericity, and this number right here is pretty darn close to 1, and obviously taken in conjunction with this result right here for Mauchly's test, that would indicate that we have sphericity being met. In that case, we could focus our attention mainly on reporting on the sphericity assumed output. So you can see it's statistically significant with respect to time, and then also for the time by treatment group interaction. Now, if we have a more substantial departure from sphericity, then, as I noted before, that can increase the type 1 error rate. And so these other tests, the Greenhouse Geyser and when felt, that's shown in the test of within subjects effects, those incorporate adjustments to the degrees of freedom for those particular tests, and basically makes these tests more conservative than the sphericity assumed test. So if it's a case where we are concerned about a violation of sphericity, then we might want to go to either the Greenhouse Geyser or the when felt test. Now, various authors have suggested some rules of thumb regarding which test to use under which conditions. So one rule of thumb is that if you have a Greenhouse Geyser epsilon value that's shown up here that's less than 0.75, then you should go to the Greenhouse Geyser adjustment with respect to that repeated measures ANOVA. If you have a value that falls between 0.75 and 1, then you would go to the when felt option right here. Or if you don't feel like you have a really substantial departure from sphericity, then you could just stick with the sphericity assumed right here. So you can see in this particular case, our Greenhouse Geyser epsilon value is 0.936. So there's not really a whole lot of concern with respect to a violation of sphericity. And in fact, it looks like all three test results actually yielded the same conclusion with respect to the main and interaction effects. But in more borderline cases, the adjustments that could be made using Greenhouse Geyser or when felt could mean the difference between a significant result and a non-significant result. So here we have tests of within subjects contrast, which allows us to assess the type of trending over time, irrespective of group membership. So this first row right here for time, this is basically what I'm talking about when I say irrespective of group membership. The second part of the output considers possible interaction between a trend and group membership, and I'll show you that shortly. But right here you can see that the test of the linear trend is statistically significant, or the linear component of the trend is statistically significant, but also you see that the quadratic, the higher order quadratic trend component is statistically significant. So it's actually suggestive that the data, the means are actually following more of a quadratic trend than just a linear trend. And you look over here to the right in terms of the profile plot, and you can see there's a decrease in anxiety from time 1 to time 2, but then you see a more pronounced decrease from time 2 to time 3. So it looks somewhat curvilinear in terms of the change over time with respect to the means. Now here we can look at differential trending across the groups. So here you can see that we're looking at the time by treatment group interaction for the linear component and the quadratic components. So with the linear component it's still statistically significant, but again we're seeing this statistical significance with respect to the quadratic component. And if we look at the profile plot to the right, you can see the treatment groups are shown in the different colors. So the control group is in blue, the treatment A group is in red, and then the treatment B group is in green. And you can see that the A and the control group and treatment A's, they're not very different. They're somewhat parallel. They're not exactly, but they're somewhat parallel. Whereas at treatment B, what you see is much more of a strong curvilinear trend over time. And so that's what this is actually picking up right here in terms of this test of the time by treatment group interaction effect with respect to that quadratic component. Okay, so the next part of the output, you can see that we've got the test of between subjects effects. So basically, if we average the anxiety scores across time for each of the groups, that's what this test basically is. It's essentially an analysis of variance. And you can see right here that we have statistical significance. So that's indicating that there are significant differences across the treatment groups with respect to the average anxiety scores. Just keep in mind that the ANOVA is dependent on what you find in terms of the Levine's test results are essentially any kind of assessment of equality of error variances. So you can see up here, I'm just kind of showing you the results of the tests for our Levine's test for anxiety at time 1, at time 2, and at time 3. So I'm not going to unpack all of this. You can see the PowerPoint to see to go through this discussion in a little bit more depth. Next, in the output, you can see that we have estimated marginal means. You've got the grand mean for anxiety as well as the means by time point. So this is at time 1, time 2, time 3. This is irrespective of group membership. And following that, we've got pairwise comparison. So you can see that we have anxiety at time 1 versus anxiety at time 2. And you can see this mean difference right here is positive, indicating that persons at time 1, anxiety scores were higher than time 2, this is the difference right here, and it's statistically significant. If we take time 1 versus time 3, you can see even more difference between time points, and that difference is significant. Then we have time 2 versus time 3 right here, and you can see that it is statistically significant. Okay, so the next part of our output, you can see that we are looking at differences between the groups in terms of anxiety. So this is when we selected that we have pairwise comparisons that are given right here. We've got control versus treatment A. There's the mean difference and it's significant. Control versus treatment B. There's the mean difference and it's significant. And then treatment A versus treatment B, and that difference was statistically significant. Now I also want to mention that down here it says Bonferroni. These are basically Bonferroni adjusted pairwise differences between the groups. We did select Tukey's test, so right here you can see a little bit further down the output it says Tukey's HSD, and so these are the comparisons that we had requested using the post-hoc option. Finally, I just wanted to draw your attention to the table that contains the means for treatment group by time, and you can see that the means that are reflected there are appearing over here in this profile plot. Okay, so if you find evidence of a significant interaction, as we did in our analysis, where you have between subjects and within subjects factors are interacting, you may wish to describe the nature of the interaction using simple effects tests. So an easy approach is to, after you've specified your model and all the options in SPSS, is to click on the paste button, and then a syntax file will open up. And with a couple of minor modifications to that syntax file, you can request simple effects tests. So to show you what I'm talking about, I'm going to go up to Analyze, General Linear Model, Repeated Measures again. Everything's been specified already. Everything is already set. So what I'm going to do is click on Paste right here, and you can see a syntax file is opened up. So down here where it's got the estimated marginal means reflecting the group by time interaction, if you will, what we'll do is I'm going to type in compare, use the compare command, and then inside that I'm going to type in the word time, which is the name of our our repeated measure. So we'll type in time right there inside parenthesis, and then I can also ask for a Bonferroni adjustment, so I'll just type in ADJ, and then inside the parenthesis Bonferroni. Okay, so now we've spelled it out, and so now what we can do is highlight everything and click the green button, and in our output, when we kind of scroll up here, you can see that we now have our simple effects tests in a couple of places. So first off, you'll notice that we have multivariate test results that are given. This is the control group, and this is essentially comparing, or rather testing mean differences in anxiety over time within the control group. Then we have testing mean differences over time within the treatment A group, and then also within the treatment B group. So you can see there's Wilks lambda here, Wilks lambda here, Wilks lambda here, and you can see that all three of those tests are statistically significant. So that's indicating then that irrespective of treatment condition, we are seeing significant mean differences in anxiety over time. Now, if you want to look at pairwise comparisons, you can go up here and you can see within the control condition there's time 1 versus time 2. The mean difference, you can see it's significant. Time 1 versus 3, there's the mean difference, it's significant. Then time 2 versus time 3, there's the mean difference and significant. Then treatment A, there's the mean difference for time 1 versus time 2. You can see that that difference was not significant. 1 versus 3, there's the difference and it was significant. And then 2 versus 3, there's the difference and it was significant, and so forth. So that's basically what the pairwise comparisons table will give you. Now, if we want to focus on comparing groups within time point, if we go back up here to compare, and instead of using time, we use our TX and then dot group, which is the name of our repeated factor, and then highlight everything and then run it, then we'll get that information as well. So you can see right here, like for instance with our pairwise comparisons, you can see we've got time 1, control versus treatment A, control versus treatment B, treatment A versus B, and so forth. Then you can see at time 2 and time 3 the same comparisons being made. So there you go. That's basically it, and that covers everything that I wanted to cover for this particular presentation. So I appreciate you watching.